Hi, GM. I'm Samarth, and in this video, I'm going to be demoing my minigame, TEN Survival. So I'll first briefly cover how the game works, then go to the demo, and then get a little bit into the technical implementation. So if I had to describe TEN Survival in one line, it would be Russian Roulette, but with bombs. This game is only made possible because of TEN protocol's secure and private randomness. I'll explain how in just a bit. So the premise of the game is that there are 4 players, and each player has a bomb attached to them. Along with the bomb, each player is also given a detonate button. Now here's the catch. 3 of these buttons detonate the person who presses them, while one of them detonates everyone except the person who presses it. The goal of the game is to not get detonated, and my smart contract is using TEN protocol's secure randomness to give this special button to a random player. So effectively, no one knows who has this special button, not even the one who actually has it. This creates an element of mystery and suspense, and you'll never be able to guess who actually has the button until the game has ended. This is a single player game, but if you like the idea, I had a multiplayer prototype which was in a semi-working condition and I had to abandon it. Maybe one day I'll revisit that project and make it fully working. No promises though. So in this game, it is you versus 3 AIs who make random decisions. They can choose to either detonate or pass. Now where does this randomness come from? You guessed it right, TEN protocol itself. So you can choose your position in the queue and decide if you want to detonate or pass, given of course that some AI hasn't detonated before you already. The 3 AIs are conveniently named Alice, Bob and Charlie. And because of TEN's secure and private randomness, you can be sure that they are not cheating. So for the smooth functioning of this game, there's a special token called SRV. So as soon as you register for 0.01 ETH, you get 100 SRV tokens in your account automatically. The entry fee per match is 9 SRV. If you somehow have the special button and detonate everyone else, you get 36 SRV. If one of the AIs self-detonate, you get 12 SRV. If everyone chooses to pass, you get 4 SRV. Okay, now let's get to the demo. So this is what the main page looks like. I'll connect my wallet, and yeah, you got to make sure that your account is authenticated on the TEN gateway. If it's not, just click over here and get it authenticated. Mine is already authenticated. So I'll close this warning now. And this part shows the instructions. I'll hide them too. Now I'll start game. So let me select position number 3. Log it in. Alice self-destructed. So I kind of won. I got plus 12 SRV. A proper victory would only be achieved if I had the special button and pressed it too. Let's try playing another game. This time I'll pick position 1. Let's see what happens now. I'll choose to detonate. I'll confirm. Locking in choice. I detonated myself. Too bad. Okay, one last game. Turns out gambling really is addictive. Let me lock in position 2 this time. Alice is thinking. Alice self-destructed again. Well, hard luck. So you can try the game out yourself using this link, which I'll also put in the description, and try out how good your luck is. Now let's get a bit into the technical implementation. I won't cover much of the front-end part in here, but I'll leave a link to the repo in the description so you can check it out yourself. There's one thing I need to point out though. Currently, TEN Testnet is not supported by VM directly, so you have to use a define chain function from VM to be able to easily use TEN Testnet. So if you have an authenticated account, you may have noticed that the RPC URL that you got in your wallet actually has a token attached to it, and that is what actually authenticates you. So one hacky thing that I'm doing over here is that I'm using my token as an environment variable, because if I use the RPC URL without the token, WAGMI throws a lot of errors at me. This is not ideal of course, and I'll try to find a better way. Just had to point this out. Now let's get to the smart contract. So as you can see, the register function automatically sends 100 ether worth of SRV tokens, which is basically 100 SRV. Now let's get to the start game function. So some basic checks over here, and this line transfers 9 SRV tokens from the user's account to the contract, and this line generates the base random value using brief random. So some of you might be wondering that, hey, this is not actually private and anyone can guess it, but this is where TEN protocol truly shines. So TEN uses TEs for execution, and the T uses a new key for each transaction, which messes with the randomness, thus making sure that no one else can get it. This base random value is a very large number, and we use this number to get all the other random values that we need. So in the start game function itself, using the randomness, we calculate which player gets the special button. And in the same function, the decisions of the AIs are also made. And don't worry, because the mapping is actually private, as you can see over here. So in other chains, you can just do a get storage at to get the value of a private variable, but that is not possible on TEN protocol, thus making sure that our values cannot be seen by anyone. So we use the player's position, and if the game ends before their chance even arrives, we emit this event called game ended, and similar logic for the entire function. And the make choice function accepts the decision of the user as its input. So again, we figure out who detonated who and emit an event. This function is quite large and complex, but the basic logic remains the same. And this function is for updating the address of the deployed token contract. And yeah, that's pretty much it. Thank you so much for watching. Let me know if you enjoyed the game or not. If you have any thoughts, suggestions, feedback, or anything you want to say, just leave it down in the comments. The link to the site and the GitHub repository are both mentioned in the description. Thank you.